Hi everyone, my name is Li.
My name is Weijia.
We're going to present the simulation of a non-sitting steakhouse, Ikinari Steak. As a steakhouse, Ikinari is a very different steakhouse from traditional ones, since there is no chairs. From this picture, we can see that customers are eating while standing. The restaurant expects that by eliminating seats, customers will eat their food faster so that the restaurant would have a higher turnover rate. In this project, we are going to simulate the process of how customers flow through the system.
Ikinari steak is a famous Japanese style Japanese chain steakhouse. In the February, the Ikinari steak opened his first U.S. location in New York City, and is famous for its quick service, especially for standing only and fast turnover. Ikinari in Japan is a Japan word which means immediately or out of the blue. So the concept of the steakhouse is to serve quick and affordable steak for customers. Uh, until now, Ikinari Steak has more than 100 locations in Japan, including 6 locations in Tokyo City and plan to open 20 locations in Manhattan in the next 5 years. So the goal we want to achieve in this simulation is the first is simulate the process of service. The second is testify whether Ikinari is a fast steakhouse as they claim. The average time for the customer spending in the restaurant is around 30 minutes. The next is testify whether they use this resource efficiently. The fourth is look for possible solution for cost saving, revenue growth, or other improvement. The last is how the service model of the Ikinari Steak works if they want to open more locations in the United States.
Here's the floor plan of the restaurant. There are 40 standing stations in total. And at the same time, considering that some customers, like kids or old people, might not be comfortable to stand for a long time, the restaurant provides also a sitting area accommodating 10 customers. The flow of the entity in this project customers are presented in this flowchart. When customers arrive, they would be likely to balk if the queue is too long. If not, they would decide to stay waiting the line if there is one. Then they get into the restaurant, they would get a card of a table number from the server. Customers then walk to the butcher station to order the steak. The butcher will cut and weigh the steak in front of customers and ask them how they want it to be cooked: rare, medium, or well done. Then the steak will be passed to cook. Customers will eat their steak at the table numbers they received earlier. After finishing the food, they will check out and leave.
For the data collection, we choose Monday as a sample of workday and Sunday as example of weekend. From the chart, we know that there's a non-rush hour and a rush hour. So we pick 3:30 to 4 o'clock as a non-rush hour and 7:30 to 8 o'clock as a rush time. So here is the data we collect on site. This data shows the customer arrival time, and we use this data to calculate inter-arrival time for customers. Then we put the inter-arrival time data into the input analyzer in Arena simulation software. What we focus on is the expression. This expression we will use in our model. So here is the data for the weekdays, and here's the data for the weekends.
As the rush hour for restaurants lasts for around 1 hour and a half to 2 hours, in the simulation, we set up the warm-up period to be 30 minutes, the replication length to be 2 hours, and replication tenths. Um, Here's the overview of the model in Arena. We started by creating customer arrival. The inter-arrivals here we use are the distribution expressions we got from the input analyzer for the 4 different time periods. After customers arrive, if they see the waiting line is too long, they will decide to leave. The condition we use here in this design module is that whether the variable value of outside restaurant queue is smaller than 30 people. If not, customers will balk. Then, then we introduce a hold module to hold the queue. Since the capacity of the restaurant is 50 people, so when it reaches its full capacity, customers will have to wait in the queue outside. The hold module allows us to hold a queue when the condition is not met. The condition we set here is the entity's work in progress of customers is smaller than 50. When the condition is true, customers can enter the restaurant immediately. When it is not true, customers have to wait in the line.
The next is assign module. This assign module we use to distinguish the indoor customers and outdoor customers by changing the entity name. The next is we use a process which name is getting a table number to simulate the queue for customer to getting the table number. The service rate is average in 0.5 minutes to 1 minute. The next is we use a process for butcher station. The average time for butcher cutting steak for each customer is exponentially distributed at 1 minute. The next, we use the design module for 4 ways of cooking. As we know from the stuff, they told us the customer choose well done is around 5% and medium for 20% and for medium rare is 25%. The most recommended way of cooking is rare, which is 15%. In these 4 ways of cooking, they have different cooking time. For the well done is around 80 minutes to 22 minutes. For medium is 12 minutes to 16 minutes. For medium rare is 8 minutes to 12 minutes. For the rare is 6 minutes to 10 minutes. 10 minutes. There are 4 cooks in the kitchen, and each of them can cook 2 steaks in the same time. The next is a delay module. We use this module to simulate the time for customer in spend time in eating, which is 15 minutes in average. The next process is checkout. The average time in checkout is 1 minute. After customers finish eating and check out, they will leave the system. So we use the dispose module to simulate the customer's leave.
Here's the result we get from the simulation. We can see that most of the time there is no queue to enter the restaurant. Only on weekend rush hours, there will be an average queue of 22 people, which leads to a number of 40 customers balk when they see this queue. Also, the queue for the cooks are quite long as well. We can see the average queue for the cooking was around 17 to 18 people. In terms of the utilization rate, the cooks almost reached 100% most of the time, especially on weekend and rush hours. Um, the rest of the staff, the cashier and servers, utilization rate are on average around 60 to 80%.
Here is the result for the full time period of average total time customer spending in the restaurant. So what we can see from the chart is that in the weekdays and in the no rush hour in weekend, the average total time customer spending in the restaurant is around 30 minutes. However, in the rush hour in the weekend, the average total time for each customer increased to 52 minutes. So here's the detail of of the uh, of the simulation results. We can see is that when there's 4 cooks in the weekend rush hour, the average waiting time for cooking is around 17 minutes. So we're wondering if we add one more cooks, how the system will change. After there will become 5 cooks, the serve in this 2-hour simulation, the total customers served increased from 104 to 111, and the average waiting time for cooking decreased from 70 minutes to 7 minutes. However, the average total time for customer in the modified system only reduced 2 minutes from 52 minutes to 15 minutes.
To answer the question whether hiring an extra cook would be worthwhile, let's do some simple calculations. Hiring one cook costs around $25 per hour. The gross margin from serving one customer is around $15 to $20. And by hiring one more cook, the restaurant will be able to serve 4 more customers from the result of simulation. So it is a profitable solution. On the other hand, hiring more staff can only slightly improve the performance. The real limitation here is the capacity. Since its opening, the restaurant has been quite a hotspot for New York eaters. The ambition of the restaurant to open more branches is probably feasible. And also, as we mentioned earlier, the goal of our simulation, one of the goals is to testify whether Ikinari is a fast steakhouse, as they claim. The answer is yes for most of the time. The average time customer spend in the system is around 30 minutes. And on the other hand, we want to testify whether they use the resource efficiently, and the simulation told us yes, because most of the staff's utilization rate was pretty high. And thank you for listening. That